Hello and good day, geometry. Today begins Unit 2, which is all about proofs. I wasn't recording, but I probably gave one of the best speeches in history about why this is actually going to matter to you. You may not see it that way. Hopefully it develops as we go along. But this unit is teaching you how to argue, how to develop a logical, evidence-based argument in the mathematical sense, which you can then kind of correlate, translate to other life areas. And we're going to start with what's called a conjecture. Anyone have an idea what a conjecture is? Yeah?
I feel like it's going to have something to do with
Sorry?
It's going to have something to do with, connecting.
Sure, making connections. Yes.
Is it like an idea that hasn't been proven yet?
Yes. It's an unproven statement that comes from observation and patterns. Okay? An unproven statement that comes from observation and patterns. You make conjectures every day. Emily, could you fix that desk before it topples over and makes a loud move? Thank you. You make conjectures every single day. Okay, you wake up in the morning, you see that your driveway, your front porch, whatever, is wet. Your conjecture is, it rained last night. Okay? You may not have seen the rain, you may not have heard the rain or felt the rain, but that observation, and based on in past experiences, when the ground's wet, that comes from the rain, you make that conclusion. Okay? You can't prove it until maybe you look at your ring camera and see the rain coming down, but it's a conclusion that is made. It's an unproven statement that comes from your observations. Yes?
Are we going to get math practice back?
No, the due date is Thursday, so we'll get it back tomorrow.
Wednesday, Thursday.
I think I said that earlier, maybe it was a different class, I don't know. I told one class they're due Thursday, so I just made it true for all of you, okay? In inductive reasoning, are conclusions made based on conjectures, or based on a conjecture. Okay? So seeing the wet pavement and determining that it rained last night, you used that conjecture to inductively reason that it rained. Okay? These are very informal types of reasoning. They would not hold up in court, because court you need what's called deductive reasoning. You'd have to see the rain, because, well, Your Honor, what if someone came over with a giant dump truck of water and dumped it on my front yard? Okay? Okay, right? You have to have very concrete, hard evidential proof in those types of settings, but just a quick snap decision based on that observation is what inductive reasoning is. You see the top of your stove, one of the four corners or whatever is red. What is your conclusion?
It's hot.
It's hot. Don't touch it. Okay? People spend the first probably 5 years of their lives forming these conjectures in their head by touching the hot things. And okay, my brain just made a connection there, right? Red means hot. Okay? A counterexample is an example that proves a conjecture wrong. Okay? Proves it not to be true. So when someone makes an argument to you, if you are debating them, you are looking for a counterexample. You are looking for something that makes their argument false. Right? Questions so far? Oh, okay. An example of using patterns and conjectures here. It says, make a table and look for a pattern. Notice the pattern and how the number of connections increases. You can use the patterns to make a conjecture. So we've got the table made for you here. It says number of points. If there's only a single point, you can't connect a point to itself, okay, so there are 0 connections. If there are 2 points, 1 connection can be made. If there are 3 points, 3 connections can be made, right? 1 connection between the first and the second, 1 connection between the second and the third, and 1 connection between the first and the third. Total of 3. If there are 4 points, there are 6 connections that can be made, and then 5 points, here's where we don't know, or we're looking for a pattern. You do this in your math packet every single time. Those pattern block table questions, that's what this is. You've been making conjectures since 6th grade, you just didn't know it. Okay? But James was very quick to say 10. Defend that.
Because you can count it's by doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh no, it's 11!
No,
No,
you can
Wait,
see it, 'cause those-
recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go.
Could I
Very
try?
good, James. Okay? So one way, because we have the table here, one way that we can identify there are 10 is by counting them twice. Check our work, make sure we're counting correctly, right? What's another way? Based on patterns, based on observations. Emily?
So for the first one, 0 on the bottom, 0 plus, for 0 to get to 1, you add 1, 1 to get to 3, add 2, 3 to get to 6, add 3, 6 to get to 10, you add 4.
Okay, so there's a pattern here. It's unproven. Okay, we're noticing this. We're saying that, okay, the difference between each of them is increasing by 1. So what James did is by counting them, is we're saying, okay, this pattern seems to hold. Does it continue to work? And so by counting them, he confirmed that yes, there are indeed 10. Okay? They're also drawn out for you. And the reason why this is helpful, and you've seen this in your math packet questions as well, is that if we go to figure 6, there are 6 points. That's a lot of connections to draw out. Okay? So here's where we would rely on this conjecture, which we can use until it's proven false, right? How many connections would there be with 6 dots?
15.
With 6? It'd be 16.
You add 5.
You add 5 to it.
15.
My bad.
Oh, it's 5.
Okay? Plus 1, plus 2, plus 3, plus 4, 10, plus 5, it would suggest to be 15. Okay? Now again, the reason why these can't be used in like a court-like setting is because if someone claimed this, the defense would say prove it. Right? You have to draw it out anyway. Okay? But in the mathematical sense, to draw these conclusions, to get to these types of things, where you could eventually perhaps prove something, you're making those connections, inductively reasoning on observations, on patterns, to make conclusions. Yes?
How would you prove something like that?
You would have to come up with a formula. And so if the number of points was n, you'd have to come up with some sort of formula that regardless what number you put in there would give you the output that you wanted. So that's a very good question. So the table with actual numbers is the inductive reasoning. Coming up with a formula, that's the deductive reasoning. You can't argue a formula.
How would you prove the formula?
Well, you'd have to go through, channels, like when they prove that a squared plus b squared equals c squared, right? You have to mathematically prove it out, but that's what you do. Formulas can't be challenged once they're proven true. Questions so far? Okay, so the bottom here works with counterexamples. What is a counterexample to each statement below? You're looking for only one case that proves this statement false. If the product of 2 numbers is positive, then the 2 numbers must both be positive. If the product of 2 numbers is positive, then 2 numbers must both be positive. If someone comes to you and states this, and the best you can do is say, nuh-uh, they'll go, yaha, nuh-uh, yaha, nuh-uh, and it ends there. You're not arguing there, you're just being toddlers. You would need to provide a counterexample to prove it false. What would the counterexample be? A possible counterexample to prove it false.
2 negative numbers multiplied.
Such as?
-5 and -5.
Sure. -5 times -5 equals positive 25. You've proven this conjecture false. Okay, the product of those two numbers is positive, but the two numbers are not both positive. And obviously there's an infinite other number of counterexamples you could use, but all you need is one. Now you didn't say nah, you said no, and here's proof why you're wrong. That's how you should be arguing. Okay? James, you have a question?
I was gonna give my answer.
Oh.
2 minus 5.
If the product of the two numbers is even, then the two numbers must both be even. If the product of two numbers is even, then the two numbers must both be even. Evelyn?
Yeah.
3 plus 3.
What?
3 plus 3.
So we're doing product here.
Oh, product, 3 times 4.
3 times 4?
Yep.
Oh.
Okay? The product of 3 and 4 is even. It is 12. But the two numbers are not both even.
Oh, I get it.
There's a counterexample that proves the statement false. Okay? Next one. All functions are a straight line when graphed on the coordinate plane.
Can be a segment, parabola.
Parabola, when you graph it, right? If you look at the vertical line test, okay, this is a function. It doesn't overlap itself. Every x is exactly one y, and it is not straight. Right? Parabolas are, by definition, curved. So, what is a common example of you using inductive reasoning to make a conjecture? I used the wet pavement example at the beginning of class. What's something else that you have maybe have thought of that is something that you do based on what you observe to come to a conclusion? James.
If the water is steaming, maybe don't go in it.
Yes, if the water is steaming, it is probably hot. Okay, therefore maybe cool off a little bit first. Aiden.
If I kill someone in a video game, I'm better than them. In the video game.
Could have been a
You are talking about Fortnite perhaps. If you take someone out in Fortnite, you're better than them.
In the game.
In the game.
What if you third
But what
party?
if it was like a one-off?
Well, now we got some counterexamples coming on here, right?
If you
You have to go.
third party when they're healing in one shot.
I've
Like,
never
what if you
played
got a
it.
bunch of snipe off out of this guy?
Mario.
All the lights are off in the house, so that means that no one is home.
Okay. If all the lights are off in a house, it could mean that no one's home. That's a conclusion, a reasonable
They're
conclusion.
sleeping.
What if there's a,
It's a reasonable conclusion you might make. Now, again, this is why inductive reasoning and conjectures don't hold up in court where it has to be very formal, because what if they were sleeping? What if their power was out? Right? There are other things that could be, and so inductive reasoning does open the book up to a lot of what ifs, but you make these kind of connections all the time. Sometimes you're right, sometimes you're wrong. Maybe you are best friends with a person now that when you first met them, you didn't like them. You made a snap decision about their character based on something they did or said, but then you realized, oh, that was just a one-time thing. They're not so bad for us. Okay? Audrey.
The bread is gone, someone ate it.
The bread is gone, someone ate it,
Well,
or you actually put it someplace else. I don't know. Evelyn.
If someone's shoes are gone, then they're probably gone, like out of a house.
If someone's shoes are not where they normally are, when they're home, they might be gone.
If it's a 1v1 and you're inside already, it might mean they're flanking.
Yeah. I can't believe I didn't use that one. Perfect.
but that is true.
Yeah.
Or they
there's no
could just be
counterexample
camping in
there.
a corner.
Bria.
It looks like a duck and sounds like a duck, it's probably a duck.
There you go.
What if it's a kangaroo?
James brings up a horrible point. Yes.
When there are crumbs on a plate and someone's sitting there with an empty, and they've just finished their food, you can probably tell they ate.
Yeah. This is why parents win all the time when kids are young. You come in there, they got a big poofy cheek. Did you eat a marshmallow? No. Like, okay, I win. Yeah, Aiden.
If someone's car is gone, they're probably gone.
Someone's car's not there, they're probably gone.
Bring it on. Who's Pedro?
Just skill.
Pedro?
Pedro.
It's from the movie Napoleon Dynamite.
Oh, that guy.
Yeah, vote for Pedro. Lika.
If the pavement's glossy outside during the winter, it's probably 132 degrees.
And possibly icy, right? So be careful. Yeah, it's good to have this kind of reasoning so you're careful. You can pick out warning signs. Just a couple more, then we gotta go on. Emmett, these last three, then we move on.
What's your favorite color?
What?
It's not a
Hit
statement.
yellow.
It's not a statement.
You wanna see it? Okay, James.
If the leaves are falling, it's fall.
No. So what?
So
Like a
so
shade.
We
what?
have
Tree.
Confucius on one hand and Janushka on the other one. Just totally balanced. Audrey.
If you hear the ice cream truck,
Yes, and you'll see Mr. Schultz chasing after it. Exactly. Okay. Your assignment for tomorrow.
Man, wait a minute. Say freaking.
You don't
Come
have
on,
to do anything, but
They're looking at me.
you know my work last night.
If you hear that,
Hey, Chris,
you will know
there's a
you're-
man with free candy.
You should get in it.
If you know there's an ice cream
No, there'll be
machine
kids in the
and
van.
there's
Who's ready
kids
for a
there,
die?
Would someone borrow a text? Oh, here.
If it's one you want, and it's not a site, most people know.
Guys, I got drop camp. I'll be ready to.
Oh, come on, Phil. Schultz, how about if you assign homework, you're automatically, you lose aura. You're automatically
What do you got? Stop that. On page 75. Three through 13.
Okay.
Comma.
Of course.
What page? Oh, sorry.
And number 32
Mr. Schultz, are you voting?
and 33. Yes, I am.
Pedro.
I'm voting for Pedro.
We're responsible to vote.
Roll for
Pedro.
Voting for Pedro.
It's good to have smart people like Mr. Schultz.